So I would request all my attendees to stay connected. And, if you have any questions, you can definitely share them in the chat box and I will pick it up at the end of the session, subject to time. Okay, so my first question to Ashutosh. Do you think there is a wider adoption of the solutions today? Or if not, why do you think they're not getting adopted? And how can these challenges be addressed?
Actually, from the contractor's perspective, if I say that, of course, there are major issues are coming up to adopt these technologies or, to take these things in a future tunnels or the currently I'll say that to any of our job or the jobs we are doing it or other people are taking up or other contractors. So there are many issues are there. Firstly, I'll start with the procurement also. Like the first thing is this for many of the projects are actually, if you see, it's are heavily price driven projects are there. These civil jobs or whatever the tunneling works are there, it's are heavily infrastructure projects where the price is governing it. And the jobs are going to the how the contractors are getting selected based on the L1 process. Now, once it is becoming a L1 process, to be frank, they don't have the funds, or they actually discourage for this kind of investments because these are quite good advantage. Means these requires a huge investments that is missing. They don't have it because of the L1 concept. They don't even have that thing inside, and it's a difficult for them is to again do that. And this what is happening up because of this AI based predictive systems or the mechanized guidance systems, all these are coming out with a very huge values, which is the contractors are hesitate to invest because they didn't even put it that price into the cost when they have done the bidding or they become L1. At that time, they're the cheapest, so they didn't put this price. So that is one of the biggest problem are coming to them. Secondly, if I say there is another issue is there is a skill gap. If somebody buys these equipments also and they don't know how to use it or they are not trained to do that, there is a no use of this kind of data or these kind of the technologies they are taking up. Like usually it requires a professional who understand both. I'll say both. Why I'll say both is the conventional technology he has to understand how the tunneling is happening up and the digital technology. Once he knows both the things, then only he can utilize this thing. Use if you, somebody says that no, I purchased everything and I'm going to use it. But if you don't know how to use it, you cannot use it. So this is one of the biggest problem nowadays is coming up is the skill gap. There is not such a skill is available. I'm not saying that India is not having a skill. There is a very good skills are available, but the industry has to gear up. Right now, if you see in industry, very few companies are there. Or I'll say the contractors or the companies are there who are having these skills. Or if that skills are also limited to a very few to that companies also. So this is one of the biggest challenge that we are facing at the moment. Even to us also, when I say when we are coming to L&T point of view, yes, we are also facing this. But to overcome, we are finding some solutions, how to train it, how to use it, these kind of things we are doing up. But this is one of the again problem. Another problem, I'll say the third problem, which is coming up is interoperability. That is also become a big challenge. There are different suppliers are there, different TBM manufacturers are there, different monitoring systems are there, and different software platforms are there. Because of this proprietorship data, we cannot use as a common unified project wide digital ecosystem, which is if we do it also it's become very difficult. So this is like if I buy a TBM from somebody else or any other, I don't want to take the name, but if I want to take from A and if I take it from B, what is happening of their system, their formats and their software compatibility is completely different, which is I cannot use it for my other TBM. So there is no interoperability. This is again becoming a very huge cost for us to make it things in a one go. So coming to all these points, I can say that yes, cost is one of the biggest factor which is coming up. Second is skill, and third interoperability. Now coming to what has happens when somebody is ready to spend, I can say that yes, if somebody is ready to spend, in a long term, yes, there is a very good benefit is coming out. Like if you have a long tunnels, long metro job, a kind of things are there where the project value is quite big, you have a very long tunnels are there. This really helps in a long term benefit. Like I can say it can improve your safety. As I told earlier, it includes your safety part, improve drastically. It reduce your downtime time. It optimize your maintenance part. This gives actually a benefit for me during the construction. But my initial investment is very high, which I can do it if I have that money or if I have that planned in my cost during the tendering. So that way, this is making a difference. Now, to address these kind of challenges, what I suggest, or I think one of the best point has come out, even like Dr. Maxwell was also telling us, like in their project, what DSST he is talking about in the Singapore, they made it, it's a compulsion by the government or by the client that this they have to use this data platform. And with the use of this data platform, everyone has to be compulsion, and it can be provided, by the employer side, so that the all these things, the cost which is coming to the contractor or where the contractor is hesitating for this can be resolved. That is or otherwise it is known to everyone and it is a compulsion for the contractor to put that cost when they are bidding up. So that is one of the point which can address actually this challenge. Similarly, the standardization of the digital part or the data sharing protocols, that also, like what Dr. Navani was telling us, that there is lot of data are there. There is means if the proper geotechnical data are not done it properly, or if it is done it properly also, if that data is there, but data is not shared properly with everyone, like in India, like there are plenty of agencies are doing it, plenty of data in nearby area, but it is not shared with someone or the project owners or other things. If that can be come out in a proper way, or it can be a common digitalization system is there with a government, which can really helps to the contractor to earlier knowing all these things can help us to take this kind of issues and take out this kind of challenges. That is one thing is there. Third part, again, I'll come back. The last challenge that what I'm saying is the skill. What we are saying is that we have to develop the skilled people. People, there are good engineers are available, lot of engineers are available, but the problem is they have to get the training for this kind of products, how they're using, and much more they have to do it so that they can give a the good solution to the project. For doing that, there is a collaboration is required between the government and by the contractor, consultants, and academic institutes also. Because in India, if you see right now, very few institutes are there who are actually talking about the rock mechanics, what sir was talking. There are very few people, and if you see, there are very few graduates which are coming out every year. So lot of development is required to be done it from the educational point of view also, and giving a trainings to, so the contractors, or I'll say that the companies, like the bigger companies, should make their own academies kind of thing where they can train their people, and then after training they will be there on the site, which really helps. Because of this only we can come out with these kind of challenges. So in my view, I'll say that for successful adoption of these kind of things, the main people who are really required, to come into picture it's a client, contractor commitment, and industry wise also it has to be, come out as a common platform kind of thing should come out. If these things will come up, yes, smart tunneling will become a more standard, and rather than become, like exceptional. At the moment, it is exceptional in India. So if these kind of things will come out, it will become a more standard practice, and we can do much faster the things like what Novani sir was talking about, 800 meters. That can now not become a record; it will become a general. These kind of things can happen.
Thank you, Ashwin, for
Thanks.
sharing those insights. It was truly insightful. Can I have Dr. Angus' view on this? Can I have your view? Especially on the
Yes.
aspect of interoperability and data.
Yeah. First of all, in our experience, you're absolutely right. When asked to bid competitively on a job, people will not generally include things that aren't asked for. And they'll only include what has been asked for. So the first thing is, if you want systems like this, please, consultants writing specifications, write them in. Now, that may not be the optimal way of doing it. We found actually that if the owners take responsibility for providing systems across projects, particularly where a project may have multiple contracts, then they can set a standard that works across the contract, and actually they get the benefit in the future of all that data collected in very standardized ways that can be used to manage claims on the actual contracts, but also looking at future contracts and may do in the next few years. And going back to Dr. Nawani, what he said, about making sure that data is available, that data that is collected on jobs, it's gold dust. Anybody doing tunneling into similar conditions anywhere else would really like to get their hands on all that previous experience of tunnels that have been done in similar environments, so they can actually get that understanding for how the ground really behaves. How does it vary between borehole to borehole? It's really, really important that data remains available and is shared for the betterment of the whole tunneling community. So in terms of interoperability, I started this company because of the difficulties I had as an engineer on a project to getting my hands on the data. And when I got my hands on the data, I found that the data was, in a lot of cases, unusable because they hadn't recorded it certain fields or they hadn't recorded it a certain way. I had to do a lot of work to actually put that data into a format that I could use. So our goal as a company was to create platforms that were very, very highly configurable and then would allow people to access data themselves, for the data to be complete, for the data to be high quality, for it to be standardized, for there to be an ability to operate from program to program via a system like our Mission OS platform. So to do that, we have created APIs. Now, APIs are the way in which computers do talk to each other. So within Mission at the moment, people who maybe want to use design software like Plaxis or FLAC or whatever, they want to use instrumentation or use program, they can actually communicate to Mission and get data out of it. And it's there, it's audited, it is complete. And similarly, we want Mission to be able to get data that's in digital formats in these other programs, being able to absorb that into Mission so it can be maintained in that digital format, so it can be used by engineers as engineering data. The number of times we see numerical information that goes into its final resting place, which ends up being a PDF report, it's dead. By the time it gets into that PDF report, the data is dead. I know you can sift it out using AI these days, but really anything that is numeric or organized data should be kept as data so that people can use it all the way through jobs. So really, the company I created was born out of my frustrations as an engineer at having that interoperability problem that Ashutosh mentioned. It is frustrating, and I really appreciate that. So we have put a lot of effort into trying to make sure that people can get to the data they need, and if they can, confidence in projects goes up. If confidence in projects goes up, speed of projects goes up. We've seen this time and time again.
That's great. Thank you. So I want to come to Dr. Navani for my next question. So I think you already touched upon how important it is to have the geological investigations in place, even though you have a lot of digital solutions and other things available. So today in India, we see that metro systems are moving increasingly into congested urban environments. So one thing that you've already emphasized is the geological studies. So how do you think, real-time monitoring and TBMs and the geological investigations can work hand in hand for a perfect or, for a successful tunneling project?
When you're talking about the urban areas where you see a lot of infrastructures are there already, and then you're going for the tunneling there, you never know what the geological complexities are there underground. So for that, you see, the same point comes that you have to have the total knowledge about that. These utilities, whatever are existing, what is the level of that? You should know what is the groundwater level, because the problem lies with the water ingress and that is the main culprit. I'm telling you, whatever the medium is, even if you are passing through the quartzite, very hard quartzite, or you are passing through the granites, but if the joint system is also filled of the groundwater, you just think that, you see, it behaves in a very different way. Then There you see the first thing what you have to do is that for the collection of the data, that geophysical surveys should be done, because you should know where is the soil cover, what is the level of the weathered mass, what is the level of the firm bedrock, and all that. And then you should know the utilities at what level they are. And then with the drill holes, you should confirm it. And at the same time, you should know the what is the water table. Now, if you have all these data, then you see, since we are using in India tunnel boring machines, even for the earth pressure also and the rock cutting also. So there is no problem, because kilometers we have made by TBM. But prior to that, we should have all these details, because you see, the tunnel is designed using geology. It, no other factor you have. You may use anything, you may use any technology, but you should be well aware of the geological variations, the rock mass classification, how the behavior is. Then the changes, it is coming variation, that there are some shear zones, there are open joints, there are filled joints, and then you see the scenario is changing very fast. In Delhi, suppose we make it, then it's a quartzite, fine. But then suddenly there will be, because it's a topography is such that you see you have the quartzite ridges, and then you find that it's full of the alluvium or soil. So suddenly you come across the, so all these things, if particularly along the alignment of the metro, we don't have the geological inputs. And of course, for the fast or the smart tunneling, you see, this geological data should be digitized. And if it is done, then AI associated predictions can be also made, because these are the ones which are coming in the future also. With the geological data, huge, I'm telling you, enormous data is collected, and the mapping is done when the excavation is being done on 1:100 scale. But unless it is now, because if you want to go for the fast, then we have to have a same track also, same pace also rather, and then for that we have to go for the digitization, AI association. Associated decisions has to be taken. So my prediction should be based on that. Tunnel seismic predictions are also there in the tunnels. With the geophysics, what we do is that we are putting the that geophysical equipments there, and then we can predict up to 150-meter ahead what is going to happen. It's fine, but sometimes it's very difficult to stop the work there and then wait for that prediction also. Sensors we are putting, no doubt. And I don't know whether you are aware of the fact that you see in Tala project, hydroelectric project in Bhutan, the cavern for the powerhouse, the support system given there is the rock bolts, very long. Now they are just moving from one wall to another like arrows, because of the fact that stresses are so high. It is a Himalayan terrain and it's not properly studied. So again, I'll say that it is possible. Everything is possible. I'm all for the smart tunneling, but we should have the adequate geological digitized data so that a proper design is done. That's it. That is my contention in this.
Thank
Thank
you,
you very
sir.
much.
Yeah, thank you, sir. So my next question to Sanjay Sanyal, how do you think, what design principles and engineering aspects should never be compromised in metro tunneling projects? Smart tunneling is doing its duty, but still design principles, what do you think they are, which design principles should never be compromised?
Principle of designing is safety for workers, passengers, adjacent structures, and for public. At no instances this safety should be ignored. When I talk about safety, like the segment lining system should be robust to take care of any eventualities. It should comply with all codal provisions. The AI prediction can fail sometimes. It cannot be 100% foolproof. The system may stop working, provide some inappropriate prediction. We should be always aware of these aspects. The system may fail, but our design should be robust, and it should be based on basic principle of engineering and judgment, and it should satisfy all our legal as well as technical uh, mm, requirement for the project to ensure public safety first, and then safety for everyone, all stakeholders in the project.
Thank you, Sanjay. Ashutosh, can I have your views on this?
I can say that what is happening up when we are saying, particularly for the design point of view, what he's saying is very much correct. Yes, the first principle of the design to be followed, segments to be designed. See, nowadays, what is coming out is everyone is, there is a design is for 100 years and all that pictures are coming up and all codes are to be followed. So that everyone is doing it. I 100% accept it. But the point which sometimes people are missing up is, the fire safety requirements. There is one of the key feature which is missing in most of the previous tunnels also, and now I think it is improved drastically. I can say that the NFPA guidelines have come up, that guidelines are following now in all metro tunnels. Now that is following up, but during the emergency time, the evacuation part has to come out very clearly. That is one of the things that everyone has to look up drastically during the fire time. If the fire has happened inside the tunnel, whether for that, what is happening, is there the tunnel over the segments and all that things can take up that kind of load, whether the tunnels can take up. Of course, yes, these are some additional costs are there to the project, but these are the things which we have to now improve, which was as our previously the main tunnels and all that, these were not there. So this something is we have to improve it, because nowadays these things are quite possible, it is happening up. Sometimes people miss these things, or sometimes there is a small error is happening up which we don't know that, and which come out later on after some time. So there is like latent defect kind of things are coming up. So these kind of thing, to avoid that, definitely we should take care of these kind of codes also. So that I suggest that should be followed everywhere strictly, particularly for the fire safety related things.
Thank you for that. Okay, so now one question that I would like to throw to everyone is India, uh, we are importing a lot of technologies and instruments from abroad, like from global players. So why do you think we need to be importing? Is it because we are new to the smart tunneling as such, or do you think there is some capability gaps behind this reliance? And how are we supposed to upgrade ourselves? So this is a question to all of you. Anyone can start. Probably Ashutosh can first start and then follow it with the others.
I think yes. I'll answer you first. Is that as a from a contractor side, I want to bring it out this particular point. See, what is happens is, yes, we are completely the first thing that is come out. If I give you a simple example, that this apart from the technology part, the TBM for any tunneling nowadays to do fasting tunneling. Right now, TBM is not manufactured in India. It is coming from outside. Why it is not happening up in India is the investment is quite huge. It is very difficult for a companies, to do the investment. And once it is done, it also, suppose the case is like, if I start making a TPM, there is the push is required from the government also, which we are actually lacking at the moment. Or I'll say not only from the government, from the employer point of view also. What has happens is, when I want to make a TBM, or when I want to make a new AI software, or I want to use it any new technology, the first question coming out from the employer is where you have used in the past. I really don't know how to answer that question. This is a new technology. This is the first time I'm bringing up. How I can say that I've used somewhere in the past, or how it is. The client should come out. They also should be robust, and they should take this kind of challenge. Yes, we can try for this. see, I am investing this much of money, I am bringing out all these things so that I can use it somewhere. But if I don't have any project where these things are not allowed or this thing is not happening up, how I can try it? So this is one of the biggest problems. See, Elon Musk can do that. He make his own TBM, he make his own tunnel. He has that much of money but as a Indian contractors, people cannot do these kind of things. I cannot make my own TPM and I can try it, and then or my own software still I'm trying it. I'll say that yes, to the extent the investment is less and trial can be done it is not impacting much of the thing because we have some of the solutions. Some of the big companies are doing that, like us, we are doing it. We are developing in-house lot of softwares. With that softwares and AI techniques, we are driving it. But again, yes, this is not the one point solution what we are looking for. It is like, okay, one few guys can do that, but not as a mass. So we need some this kind of the support from government who can help. And lot of government I'll say that the institutes where there are very very capable professors, and the I'll say that professors are there and the students are there who are actually studying and doing these kind of things. So if we can develop them and give some sanctions to them so that they can develop something more, that also can help up. So this challenge can take out if these things can happen it. Otherwise, yes, we are still dependent on outside countries where the major tunneling is happening and they are utilizing it, where we are not able to do that.
Okay. Dr. Navani, can I have your views on this?
Rightly told by Ashutosh that you see, presently we are not in position to do it because of many reasons. But recently I came across that Bharat Earth Movers, they have been given this task by the government to make the tunnel boring machines to start with. I do not know the status of it, but it's a beginning. And maybe that you see, with the political will is there, this will happen. It doesn't require much in that because you see, uh, as per the present government's slogan that Atmanirbhar Bharat, yeah, that is there. You can. But then you see, what I have seen mostly that uh, presently the success story, I must add, success story of tunnel boring machine when we look at in India. Failures are many than the success. Particularly when we go for the tunnel boring machine for metro, there is no issue. There are very successful things happening. But when we go to the Himalayan region, tunneling becomes a big problem for the rail tunnels and all that. Even for the hydropower projects tunnels, it's a very big problem. Projects are delayed, cost overruns because of the fact that it is TBM is stuck up. I know one case of the NTPC project, that is the Tapovan Vishnughat project in the higher Himalaya in Uttarakhand. So we are using the TBM, fine, from the outside. And then everything is thrust upon the contractor. Well, suppose the cost of the TBM is about 200 crores. They say that it is the property of the contractor. But if it is stuck up, the cost overrun, the delay in the construction, then blame to the contractor, then this happens, I know. Then the blame in all the collapsed tunnels, whatever, whether it is TBM or it is conventional tunneling, first thing for the reassessment goes to geology. The geology was not good. This failure is because of the geology. Whether you bring the TBM from outside or you construct you manufacture in India, but the same problem remains that you see our country, the tunneling is mainly being done presently in Himalaya for the hydropower projects, for the roads, road tunnels, for the rail tunnels. Now, in that scenario, when look at, sometime it gives me a rethinking whether it is right to go for the TBM in a terrain where you see the geology is very complex, tectonics is very active, stresses are very high, and we go with the same design everywhere, and then the assessment of geology is also not possible because it is only the cuttings which come from there. We try to assess from there. So, like that, you see, my point here is we have to see the other side also, whether really at the moment uh, TBM is functioning well. Parvati projects of NHPC, it was delayed for long. So, success story has to be seen, and then you see suddenly what happens. I can quote here of this THDC project. The assessment was done that the tunnel, the river borne material, that deposit is only 20 meter. It came out to be more than 80, 100 meter, like that. And tunneling through the RBM, who is going to make it? An entire project was delays for about 3 years, 4 years. So we have to be very particular about whether the terrain, you see in Alps and in the European mountains, the stresses are not that high. They are not that complex. Himalaya, it is, you see, the tectonics is playing a big role. Many shear zones, faults, and then stresses are very high. So we have to look into that aspect also. In the urban areas where you are going for the tunneling, fine. There is no issue. You are just passing through the. But in Himalayan area where now you see major projects are coming, whether it is Bhutan or it is Nepal, everywhere we are going for the tunneling. And big hydro projects are coming. Arunachal Pradesh is the big center now for the hydropower projects. I was working in Arunachal in the Italian projects when I was working with other company after my superannuation. Jindal Power, Euro 3000 megawatt project. So you see, uh, practically we have to think of. It's fine that you see technology advancement has to be there, and we should adopt it. But at the same time, we should see whether the terrain is compatible for that. That is my submission here. Thank you.
Thank you, sir. Dr. Angus, can we have your thoughts?
Well, I'm not the best person to talk about India application of India technology, but we, as a company, we have invested very heavily in India. In fact, some would say our technology is made in India. We have our R&D center in Kerala. Yeah, I would say that over 95% of all of our projects are outside of India, which poses a question: why aren't we doing projects in India? And I think really our experience is that it's as we said earlier on. It's something that because they're competing on price for project, there is no budget to invest in these things at the beginning of projects. We also find that engineers being engineers, sometimes they will want to try and develop their own systems initially. Now that's a 10-year exercise, and to do the kind of things that we've done. But sometimes people do get through that, then only eventually will they sort of say, okay, well maybe we should have looked around to see what was on the market. So I don't know. We would obviously like to do more projects in India with Indian companies. As I say, we're there. We have 110 people waiting to do that. So I can't give a magic answer as to why, Indian companies aren't using Indian capabilities.
Thank you for that. And Sanjay, can we have your views on why and what
Yes,
gaps still
Ashwin, to sum up,
exist?
I think this capital intensive project, and we need backing from government and policy. If we can win mission Mars, we can kind of ISRO is doing. We can definitely make a TBM. The only thing we need capital investment and encouragement from government is what we needed. We have capability of doing it.
Yes, thank you. Okay, so I think I'll have a few more questions to ask. So one thing is like, smart tunneling has enabled a lot of things for us. So what it could be, I mean, what are the advantages that it offers, like, in terms of vibration or safeguarding of heritage structures? Why do you think smart tunneling has to be adopted in India? I think it's a common question. Anybody can start. Like probably I could start with Ashutosh again.
Yeah. Yes, I can say that smart tunneling is really helping out to come out these kind of issues also, like the heritage buildings and other things also. The quite old, not only heritage, like old buildings are there, or which are loosely made it long time back. That time the things was not happened. So it really helps. So what is happening up is how we can do that. It is coming out with a real time monitoring, which is actually one of the very good solution nowadays are coming out, and which can be integrated with the tunneling TBM machines also, and during the conventional methods also. Both the cases it can be integrated very well. I'll just give you one good example is what we also have done it, like in Mumbai. When you see that Mumbai, we have also the Mumbai Metro Line 3, the tunneling work was going on for the Mumbai Metro Line 3. At that particular time, we are also going very close to the heritage buildings. And, the time at that time, the very first things are coming up. You are in Mumbai. Mumbai is a very, commercial place is there. A lot of people are there. And these kind of buildings are very old heritage buildings. And you have to drive a tunnel below that. And it's a compulsion because the time requirement is telling that we have to complete the tunnel for the metros. That metro, which should have been there 50 years ago, but they have developed now. They should have done it 50 years back, but they didn't do that. So that heritage could not be heritage at that time, but now it's become heritage. So because of that, we have to start digging below that and start doing it. What we have done is we have brought up entire, all these buildings for real-time monitoring was there. And these are all connected through a system with integrated system with our TBMs also. So every second, when it comes to real-time monitoring, that means every second it is getting monitored. With respect to that, we able to reduce the vibration also, like the TBM we are planning up, like when the TBM is moving below this area, or 30 meters beyond that also. So what we are doing up is we are slowing down our TBM. We are monitoring all our vibration systems with how much vibration is going about to the building with this real-time arrangements, and we are slowly we are moving up. So this is what we are saying is that the predictive thing has started coming up. So because of this real-time monitoring, we can predict how we can move ahead, and all that things can happen. So yes, this smart technologies really helps us for going ahead. What we are doing up, if it is not a heritage building, when it comes to heritage building, that means nobody is living in that. It's only a monument. It's a kind of heritage. But apart from that, there are other buildings which are quite old, which are not heritage, but yes, it is poorly made it. And what we are doing here is, yes, because of the real-time monitoring, we can make sure the life of the human also can be done it. So what we do is that we allow all the people to come, to shift somewhere else. Since the tunneling is happening up, there is a chances, and there is a chance that it can collapse because that structure is not stable. So with the vibration of the TBM, so all this, we can get it done through the real-time monitoring. So that is one of the thing it's really helps. So that if we are using up with all the sensors and everything with the geotechnical instrumentations, all sensors of the instrumentation and the real-time monitoring, it can help. So it can help, to work near the heritage structures or these old buildings also. So this we should utilize fully, and then that can help. This what I can suggest.
Thank you. Dr. Angus, can we have like what, I mean, some advantages are obvious. So what
Y-
else does it offer?
Yeah, I mean it's not just heritage structures. It's also existing utilities and existing national assets that are currently in use. So, for instance, in the UK now, some of you have heard of HS2, which is a huge project, over £100 billion, And the alignments of these tunnels that they're building go actually along national infrastructure highways, including the main line out of London to the north, goes to the main roads, the big viaduct in Birmingham that goes through. Now, the consequences of downtime at any of these assets are huge, and the consequences of downtime on the job as a result of uncertainty over any of these assets is huge. So on this project, there's almost 170,000 instruments been installed, most of which are actually being recorded in real time. And that's to provide assurance to all of the stakeholders on the project that the project is being delivered safely. And because that's happening, it means that there is that sort of level of confidence. And I mentioned confidence before, confidence that everything's been looked after, everything is there, and it means that the jobs can go efficiently and can go quickly. It doesn't mean to say they go quickly because things have been overlooked. It's because they know that things are being looked at, and that's very, very important.
Thank you. Sanjay, can we have your views on this? What are the obvious advantages, like I think we've discussed, like anything that's exclusive that smart tunneling is offering us?
Smart tunneling is not smart in that way. It is a technique, not only AI, other things that we use to make our decision more smarter. Like I have seen while I studying in Austria, they are doing research on smart dust. Like they are going to put some chips in segments during casting, and so they will give lifetime data about like anything, if it is fire, if it is water, if it is crack or stress develop. So that kind of thing which comes under smart tunneling. It is also like how we are going to predict geology or before we excavate. Like if it is in TBM, I think there is another technique called GSM. One software company is there for rock science. They can really from distance they can say with a kind of joints, kind of like they can give you all the geological features even from distance through satellite imagery. So our high density image capture cameras. So these are the things which make our decisions smarter. It is not the panel which becomes smart, but the way we use. I refer that this is not only AI; it is an overall management of advanced technique which help us to decide in advance and reduce risks for the tunnel, simultaneously optimizing our design and our decision making.
Thank you, Sanjay. Dr. Navani, your views, please.
Yeah, we have some experience about, and when this metro tunneling was being done in Bangalore, that time we are passing through the Vidhan Sauda. That is the place where you see chief minister, MLAs, they all sit. And so it was a very difficult place because some people, they have informed the chief minister that time, I think he was Mr. Yadurappa, that tunneling is going on and maybe that you see this building may collapse or something like that. So rightly told that you see if the monitoring is being done properly, instrumentation sensors are there and all that. So we can do with the minimum vibrations. And this happened. Even we had invited the chief minister that whenever you feel time, that time only we will be passing just below the Vidhan Soda, and we crossed it. And he was so happy. So these are certain things that you see, we can use the technology with due care, and then the best part is the monitoring, instrumentation. The only thing is that, or the smart tunneling, the smart, rightly told by Mr. Sanyal, that smart decisions are required, because technology is smart, but if the decisions are not smart, then you see it may not work properly. So both the things, and I mean, a combination of geological intelligence, then the work course, then technology, everything. If you see this proper combination is there, this becomes the smartest tunneling, and you can do it very fast. But if the coordination is not proper and things are not moving as one, then you see this may go in other direction. That's there. Thank you very much.
So, do you think there are? I want to put it up to two parts. One is related to India. What codes are governing, and what still needs to be done. And a particular question to Dr. Angus, like what global codes are there, or like what can be adopted in India? So anybody can start. Like probably Dr. Navani can start, and then followed by Ashutosh, and then Sanjay, and then Angus.
You see the codes when you are talking about, because I had been also associated with Bureau of Indian Standards, and I was on there for the last 22 years as chairman of one of the department, that is water resources. But what happens, when we are making the code on smart tunneling? I do not know, because so far I have not come across any code like smart tunneling. There are codes on the tunneling. There are codes on the geological investigations for the tunneling. But smart tunneling, I have not come across in India at least. Now, this smart tunneling is coming now very much, and though we have been using TBM for the last many years, it is not that first time we are. But after the coming into use these artificial intelligence and digitized data, then many other things are coming. You see, we are the persons, you see, already around 55 years before I left the studies, and already 15 years have passed after my superannuation. But we talked a lot, no doubt, but not much has been done as far as the codes are concerned. So this is a very good topic, and I may also initiate in state these standards, the Bureau of Indian Standards or ISO or somewhere. You see, we should definitely go for it. But the only problem with the codes is the codes are not mandatory. We make so many codes, but then suppose somebody says that I am not following it, then maybe that there are some inquiries or something like that, or technical audits, that why you have not followed the code. But suppose I say that every 10-meter along the tunnel you have to go for the drilling to get the data. Physically, it is not possible in the Himalayan terrain where the topography is so varied, and then you see variations are so that you see you can't take the drilling machine. So our codes then where he will follow that? Then you see they will go with the minimum all along that 10-kilometer tunnel. Only 10, even the 10 are not there. 5 holes are there. With that, they are interpreting. So there are so many problems, you see, with the terrain and all. But if the codes are made considering all these aspects, why not? The experts can definitely discuss and then finalize the things. Because in this direction, we have never thought, I think, in the code factor of it. It's a good idea that it has to be discussed, and then code should be formed for that. Thank you very much.
Thank you, sir. Ashutosh, can I have your view?
Yes, I'll say that definitely coming to the code part is what is happening. Yes, we are having a codes. I'll say, see, first of all, is it's about the the natural part. I'll bring it up, like how we are doing a tunneling. It is not about the smart or the conventional like that. When we are doing a tunneling of anything, the structural design is the core part, which is coming up for the stability of the tunnel to be there for the longest 100 years or kind of thing. So when that thing is happening up, we have Indian standard codes are there. That standard codes we are following up. Everyone, like I really say that, of course, for the construction point of view, I don't know that if some places it is not possible, it's happening up, but I can say when we are coming to the urban areas and all these areas, 100% the codes are followed. Whichever the Indian codes are there, or ASTM codes are there, or British standard codes are there, that are following up. People are compulsory following up. But the problem what is coming up are our codes are also quite old. When you say that our codes are, it's like 20, 30 years, 40 years old. These codes are not being revised, or they revise it also very minimal to that. So what we are doing is to come up these particular points. Even in various other forums, we have also commented this particular point, and so many very senior persons from our company also are representing to the codes there, where we are telling them these codes need to be replaced, or it has to be, changed. They have to bring it up new things into a picture. Like a simple example that I'll start bringing up is, one of the point that every time I'm telling, when we are saying the conventional tunnels, people are talking about the rock bolts. Rock bolts are never been considered as it's always been as a temporary. But nowadays, rock bolts are available for 100-year design. But but that is not coming up into any of the code. All codes are saying that rock bolts are temporary. Then second thing is coming up. There is like when you come into the tunnel segments, steel fibers are allowed. Everything is like in many of the other countries, you can see steel fibers are there. They are using it alone. Here in India, still it is, few time back, DMRC has come out with the steel fibers in a segment, but still people are not able to use it because it has not been used anywhere else in India. Till now, there is no single tunnel. Of course, yes, we have to add some reinforcement. Again, I cannot do 100% steel fiber, but there is no code, there is no preference. I have to bring it up something and then I have to show it. Okay, this is what has happened in past, or this is how things are happening up. So we have to develop our codes. Our codes are there, it's quite old. We have to get it changed. That is required. And there are plenty of time to, how this will get changed. It will get changed is like somebody has to tell them that this has to get it changed. So like in various forums like that, when we are talking like with here and known places, we are talking in the forum that these codes need to be changed. That has to be done it. Coming to the next point is what Navani sir told very clear or correct also. When we are talking about smart tunneling doesn't have any codes. There is no code for smart tunneling. Smart tunneling is a way to do the tunneling smarter way. It is not like there is some code. Smart tunneling, what we are doing, the benefits which are coming up, it can give faster and more accurate decisions. It can be decision making, I can say. It can improve your safety. Predictive risk is there. Risk managements are there. Construction delays can be reduced. Rework can be done. So these are the benefits of the tunneling. But there is no codes for this. The codes are there for the structure. That is the basic principle that we are following up. That has to be there. But it has to improve.
Thank you, Ashutosh. Can I have Dr. Angus from a global point of view, or like what would you like to see as the best practices that need to be followed?
Yes, I mean, one of the big practice guidances that have come out over the last 20 years really is the Code of Practice for Risk Management of Tunnel Works, which is an ITA publication driven jointly by the insurers and by the tunnel community itself. And in recent episodes of that, it has talked about smart tunneling, particularly the use of data, and also particularly the need to quantify uncertainty on tunnel construction projects. And by quantifying uncertainty, it really does focus people on taking measurements while they're doing projects to be able to get feedback on whether designs are working as per their intention. And just going back to Ashutoshi's comment about the sort of the segments, for instance, we did a project in Hong Kong where we put embedded instrumentation into both conventionally reinforced segments and fiber reinforced segments to gather that data, exactly the kind of data he was talking about, to be able to prove the performance of fiber segments so that they could ultimately be used in the works. And it was only about 10 years later that we managed to convince the Hong Kong government to implement the segments due to the data that was collected. So I think there's a sort of thing where smart tunneling can actually drive changes in the codes of practice, which is great because it's collecting data, it's using that data to be able to guide how codes can be developed in the future.
Thank you all.